So I honestly didn't know what to expect from the ZimaBoard 2. But after a week of testing and seeing what this little guy can do, I think it might actually be time for me to get rid of some of my servers. Maybe. And the timing for this review worked out pretty well because I've been kicking around the idea of adding another Proxmox node, and this was a good excuse to see whether the Zima 2 worked better as a Proxmox host or maybe as a Docker hub running the pre-installed Zima OS. And just for transparency, IceWhale did send this review unit over along with a few additional accessories that we'll be going through, but no money changed hands, and as always, this is going to be my honest take, and they have not seen this video before you have. The ZimaBoard's packaging is actually super cool. IceWhale sent this layered corrugated cardboard design, and if you sort of trim off the top, you turn this into a little dock for the ZimaBoard itself and two 2.5-inch SATA drives. Now, if you've never heard of the ZimaBoard before, or if you've never seen it, it's kind of like what you would get if you crossed a Raspberry Pi with a home server, or maybe if a NAS and a server had a baby, and a pretty smart baby at that. The ZimaBoard 2 has some real heft thanks to the all-aluminum enclosure, which doubles as a passive heatsink. Connectivity is surprisingly generous also. You have dual SATA ports, dual 2.5 gig Ethernet, 2 USB 3.0, a mini display port, and what really sets it apart is this 4-lane PCIe Gen 3 slot, which we'll be using with our nvme adapters later on. This unit has 16 gigabytes of RAM and 64 gigabytes of onboard eMMC storage. The base home server package comes with 8 gigabytes of RAM and 32 gigabytes of eMMC storage for $279 on their website, while the upgraded configuration like this with twice the RAM and storage runs for about $349. And both kits include the same accessories, which are the 12-volt power adapter, a SATA Y cable, and cooling fan. The ZimaBoard 2 sits right in the middle of IceWhale's lineup. You've got the original ZimaBoard, the Zima Blade, and the Zima Cube on the other end, which is more of a full NAS or home server solution. This second generation board basically doubles down on the original idea with faster networking, newer CPU, and updated PCIe support. All of them ship with the ZimaOS pre-installed, which is IceWhale's customized version of CasaOS. You can get up and running almost immediately. So I started by connecting two 2TB Seagate Iron Wolf hard drives using the SATA Y cable and slid them into the storage bay, instantly turning the ZimaBoard into a sort of a small NAS setup. After connecting networking and power, the status LED on the board lit right up, and since this board is sort of designed to run headless, I simply scanned my network and saw Zima 2 appear and jumped straight into the web interface. And once inside Zima OS, both Seagate drives were automatically detected, so after a few clicks, I created a RAID 1 mirror and left the default name of Safe Storage, which, as cheesy as it sounds, was apparently the best I can come up with, so please don't judge. Zima OS is based on CasaOS, but IceWhale has tweaked it better to fit the ZimaBoard as a small server platform. Everything runs through a browser-based dashboard with its own app store, and under the hood, the apps are basically just Docker containers, so most services install with a single click, and you usually don't have to mess with command lines or YAML files. You also have widgets for storage, networking, and system time, and there's even a built-in version of BTOP for a quick snapshot of system resources. Under settings, you can adjust things like your time zone, search engine, and wallpaper, but it did take me a minute to find the toggles for SMB, HTTPS, and the SSH access since they were sort of hidden under developer mode, which felt a little odd since these are pretty standard server features. So I decided to spin up a virtual machine of Linux Mint using Zima's Virtual Machine Manager. I hosted the VM on the 2TB safe storage RAID I created, allocating 100 gigabytes of storage and 4 gigabytes of RAM, but note that you can't resize the storage afterwards, but you can adjust the RAM and CPU cores if need be. The VM took a little bit to install and was a little sluggish at first, but seemed to even out when it found its footing a little later. I then installed JellyFin for media streaming and added Uptime Kuma for monitoring. Using the built-in file manager, I uploaded a 4K 6GB YouTube video of mine and started streaming it from my desktop browser. I then launched it from the Linux Mint VM as well, and finally opened JellyFin on my phone and streamed it there as well. There was a little slowdown here and there, but most of it was inside the Linux VM rather than the system itself. And while all of this was running, total power draw hovered around 26 to 27 watts, which lines up with the Intel N150 processor, a 4-core, 4-thread chip, rated at about 10 watt TDP, and clearly designed for efficiency versus, raw performance. At idle though, with all 3 services running but no streaming, power dropped to about 8 watts, which is much closer to a Raspberry Pi than a traditional home server or even a mini PC. So you can certainly use this as an always-on server. To really test out the media streaming and networking performance, I first ran a iPerf 3 on one of the 2.5 gig connections with no streaming to get a baseline and saw speeds of around 2.35 gigabits per second. When I switched on my media streaming of my 4K video and also ran YouTube in the Mint VM as well as streaming the same video in the JellyFin app on my phone, throughput stayed above 2.25 gigabits per second, which was very impressive and means that there is plenty of bandwidth and headroom for streaming on this guy. And thanks to the N150's built-in hardware transcoding, playback stays smooth without hammering the CPU. At this point, I was curious how it would handle a heavier workload, so I ran a stress test that pinned down all 4 CPU cores 100%, for about 15 minutes to really heat things up. Without the fan installed, temperatures mostly stayed in the mid-80s with the occasional spike into the low 90s. High sounding but totally stable with a fanless system. After the test, the temps did drop down pretty quickly, although it took about 5-10 minutes to fully cool down back to normal as the aluminum case had to slowly release the heat. Installing the optional fan required removing the bottom screws and attaching the fan assembly internally, which felt a little bit awkward. But with active cooling enabled, temperatures during the same stress test hovered around the mid-70s and peaked around 80 degrees C, roughly a 10 degrees improvement. So you don't really need the included fan for daily use, and even heavier workloads were totally stable, which gave me the confidence to push things a little further and start running Proxmix on it. So after downloading the Proxmox ISO, which was version 9.1, I went ahead and copied it over to a Ventoy USB drive. Now you can install Proxmox onto the ZimaBoard's eMMC storage, but it does require a little bit of a workaround since Proxmox doesn't officially support installing directly to the eMMC devices. I'll be sure to leave a link for the fix in the video description if you want to go that route. Personally, I didn't really want to replace Zima OS just yet, and I also wanted to take advantage of the nvme drive using the PCIe adapter. To get that started, I installed a 256 gigabyte SATA SSD into the aluminum hard drive rack using a 2.5-inch drive adapter I grabbed off of Amazon. I then mounted a 256 gigabyte Sabrin nvme drive into the PCIe adapter IceWhale sent, connected the riser cable to the board, secured it using a PCIe support bracket that was also included, and attached the nvme adapter. After connecting a mini display port to HDMI adapter to a monitor, connecting a keyboard and then my USB boot drive, I powered on the board and pressed escape to enter the BIOS of the ZimaBoard. Once in the BIOS, you can confirm the board recognizes the PCIe adapter, and then making sure the USB drive containing Proxmox is the primary boot drive. The Proxmox installation was seamless and finished in about 7 minutes, at which point I logged into the web interface and configured the SATA SSD as storage for ISOs and virtual machines. I next installed Linux Mint, Zorin OS, and Home Assistant using 4 gigs of RAM for each to see how it would handle multiple VMs. And with both Linux Mint and Zorin updating simultaneously and Home Assistant in the background, we were using about 85% of the 16 gigabytes of RAM, but performance remained smooth the whole time. There was no noticeable lag or slowdown, which was pretty impressive, and this guy can definitely work as another Proxmox mode. Next, I was very curious how the PCIe adapter handled NVMEs. I first tested a single NVMe drive using both a $10 PCIe adapter from Amazon and the dual nvme adapter IceWhale sent over, and both performed pretty much identically, landing around 1100 to 1150 megabytes per second read and 470 to 490 megabytes per second write. After that, I installed a second nvme drive on the dual adapter and tested both slots simultaneously, showing a clear uplift, but not doubling of performance. Even though, as we mentioned, the PCIe adapter has 4 lanes, the 2 NVMe drives share the same PCIe connection through the adapter, so they improve total throughput, but they don't each get their own full lane of traffic for the bandwidth. This makes the dual NVMe more about flexibility and combined throughput rather than increasing raw speed for any single drive. So it's honestly a little hard to say exactly who the ZimaBoard 2 is for, because it sits right in the middle between Turnkey and do-it-yourself. Out of the box with ZimaOS running fanless, it clearly leans toward the Turnkey crowd. You can plug it in and start spinning up services almost immediately through a clean web interface, but at the same time, it feels more locked down than a traditional Linux server. You can't really install simple tools like curl or system bench from the terminal, and features like SSH and SMB are a little bit more buried than I would like them to be. But on the flip side, installing the optional fan or mounting the board to the drive requires a little bit more disassembly than you'd expect from a plug-and-play device. And you will need your own adapter for a 2.5 drive if you want to use it in the optional hard drive bay. And honestly, whether this is meant to be a turnkey or a DIY device, I do think a physical power button would have been a welcome addition to this. But in my opinion, the real strength of the ZimaBoard 2 is that it can become fully DIY. Since it's X86, you're not locked into one ecosystem. You can run TrueNAS, Ubuntu, Proxmox, or even turn into a firewall with OpenSense or pfSense as your firewall OS. That said, it's probably not replacing a dedicated server or handling heavy workloads, at least not in my setup. And I don't think that's the goal. Where I do see it fitting best is maybe a small Proxmox node running a couple of VMs or LXCs, or maybe running Zima OS and spinning up a Nextcloud or Home Assistant, or maybe an image server for your pictures. But what do you think? Would you run it turnkey with Zima OS, or would you go full DIY with TrueNAS or maybe Proxmox? Let me know your thoughts and ideas in the comments. Anyway, that's going to wrap things up for this review. If you found this helpful, please give me a like and drop me your feedback. Also, make sure that you are subscribed to Mackie Tech if you enjoy Homelab tutorials and reviews like this. And thank you again to IceWhale for sending over the review kit. I will be leaving purchasing links with discount codes for you all in the video description. And a special shout out to my loyal Patreon supporters. You know who you are. And thank you all for watching. We'll be talking to you again very soon.